Hey team, I'm Maddie, welcome to ScienceSideUp, and today we're going to talk about just what in the world calculus actually is. And believe it or not, this is in honor of self-isolation. What does calculus have to do with pandemics, you ask? Great question. So, in 1665, Sir Isaac Newton was living in Cambridge, England. And that year, the plague, yes, the bubonic plague, made its way to Cambridge. And so he left the city and went to the countryside where he self-isolated until the danger had passed. And in that time, he developed our modern system of calculus. And here I am, proud of myself for putting on pants to film this video. All right, so what is calculus? Fundamentally, calculus is exactly two things: the derivative and the integral, and then everything else is just application and algebra. Look, team, algebra is super hard. Don't let anybody tell you otherwise. I would do calculus all day long before I did algebra. Anyway, so let's start with the concept of a derivative, shall we? Derivatives. Derivatives are born out of laziness, and there's probably a lot of math people who don't agree with me, and that's okay. But what a derivative is it looks at a curve like this and thinks to itself, you know, curves are kind of hard to deal with mathematically, but you know what's not hard to deal with mathematically? Lines. Lines are really simple. So what if we could pretend that this curve was a line? Like, wouldn't that be great? And fundamentally, that's what a derivative is. It's a way to approximate pieces of a curve as a line. So that line would be an absolutely terrible approximation for the curve, right? But if I broke the curve down into itty bitty pieces and started going like this, then that's a decent approximation of our curve, right? I've covered it in red and you can barely see the blue that I originally drew. And that's because what I did is I broke it up into teeny tiny pieces, and then we can say that each of those small pieces can be approximated pretty darn well by a line. And fundamentally, that's what a derivative does. It takes a curve and relates it to a line. To be really mathematically specific, the derivative of a function at a specific point tells you the slope of the tangent line at that point. So there's the math speak, but conceptually it's this. That's a derivative in a nutshell. So now let's move on to the second basic concept of calculus, the integral. For an integral, we're asking a different question. For the integral, we're fundamentally asking about the area of this complex shape. So let me shade it in. If you've ever taken a calculus class and you learned about an integral, you've heard the phrase, an integral is the area under a curve about 1,000 times. And that's because fundamentally that's what it is. But to kind of bring that back for a second, let's ask the question, how do you find the area of a complex shape like this? Well, the basic idea of an integral is that, again, I'm going to break it into small pieces where each piece is manageable and then add them all up. So we do something like this. So between each of those pink lines that I just drew, that's approximately a rectangle. And if I cut it up even smaller, now each piece is even closer to a rectangle. And finding the area of a rectangle is easy. It's just length times height. And so again, the idea is that if we look at the small section, then it's become something simple instead of something very complex. So again, for those with maybe a little more depth of mathematical knowledge, I am talking about a Riemann sum. And so that's how an integral works. And the other thing that's really important about derivatives and integrals is that one undoes the other. So let me give you an example of that. So here's a very simple function. The function f of x is equal to x squared plus 2x plus 5. Now let's take the derivative of our function. And I am just going to take the derivative. I'm not going to explain how to take the derivative of a polynomial function. I would recommend like Khan Academy or something like that if you're trying to learn how to do the calculation here. We're really talking about concepts. Okay, so the derivative of this function, we'll make it orange, why not? We write as f prime of x, and that's going to be equal to 2x plus 2. So now I'm going to take the integral of f prime of x. This big elongated s, that just means the integral of. So f prime of x, the derivative of our function with respect to x, that's equal to x squared plus 2x plus c. So notice that we started with our function and then we took its derivative. And then we were able to undo the derivative by taking its integral. I do want to point out that we lost information when we did that. So we know that the original function was x squared plus 2x plus 5, but the integral loses information about constants. There's some very specific mathematical reasons for why that is, but again, I'm not going to get into the ins and outs of math theory, right? So in math, things do have opposites, right? Addition has subtraction. If I add 1 to something, I can subtract 1 and get back what I started. Same thing with multiplication and division, or squaring something and then taking the square root. So if I'm able to do something to a number or a function, I need to be able to undo it too. And so that's how derivatives and integrals are related, just pointing out that you do lose information about constants. Okay, team, well that's conceptually what calculus is in a nutshell. I hope you liked this video. I hope you all are well. I've been getting some new subscribers recently, which is really great. So if you're new to the channel, welcome. I'm really glad you're here. And remember that when we hit 300, I will be giving away that dinosaur tar pit toy. So you too can have an infuriating model of a dinosaur, but yours is a T-Rex. I saved the good one for you. Yeah. Okay. Well, that's all I have for you guys today. I will see you later. Bye, team.